welcome to application 2C-5. This is your very last application before we end up our unit 2C. Our learning target is that I understand that sequences are a function with a domain of integers. So we're going to go ahead and get started. We're going to look at problem number 1 on your application. So the school cafeteria begins the day with a supply of 1,000 chicken nuggets. Each student that passes through the lunch line is given 5 chicken nuggets. We want to write a numeric sequence to represent the total number of chicken nuggets remaining in the cafeteria supply after each of the first 6 students pass through the line. We want to include the number of chicken nuggets the cafeteria started with. Alright, so just a real quick note about why this is going to be a sequence type problem instead of your typical word problem. Remember that a sequence is a function with a domain of integers. If we're talking about students going through a line, the number of students is our domain. It does not make sense to have half a student or 3/4 of a student or 1/4 of a student. Yes, we may have students that are shorter or taller than others, but they still count as one whole student. So we can only have integer in our domain because we can only count students by ones. Alright, so I'm going to start out with my first 6 students. Now this is a term that you might not have talked about in the notes. But anytime we talk about a sub 0, that's going to be our starting value before anyone else goes through the line, before we do any other operation. So we're starting out with 1,000 chicken nuggets. So that's before anybody has gone through in the line. A sub 0, or our initial value, would be 1,000. Now we can move to a sub 1, which would be after one student has gone through the line. So after one student has gone through the line, they've taken 5 nuggets away, so we now have 995. After 2 students have gone through the line, we're going to have 990. And this pattern is going to continue. When we have 3, we would have 985. After 4, we would have 980. After 5, we would have 975. And finally, after 6 students, we would have 970. Alright, so we also are asked to write the recursive definition. Remember, this can be found on your formula sheet, on the Georgia Milestone formula sheet that are laying at your tables or attached to the Mastery Check desks. So the recursive definition is a sub n is equal to a sub n minus 1 plus d. Remember, the only thing we're plugging in for on this one is the common difference. So we're going to leave a sub n is equal to a sub n minus 1. Remember, that's your previous term. Alright, and we're going to do plus the common difference. In this case, we have to look at what we're doing. We're losing 5 nuggets each time. So our common difference is going to be negative, and since it's 5 that we're giving each student, it would be a sub n minus 1 minus 5. Now remember, you would need the previous term to find any additional terms from this. Alright, just like the recursive definition could be found on the formula sheet, your explicit definition can be found as well. That's going to look like this. A sub n is equal to a sub 1 plus n minus 1 in parentheses times your common difference. So if we come over here, I'm going to do switch ink so we can tell this a little bit apart, and come over here where we're going to have a little bit more room. A sub n is going to equal a sub 1, so our first term was 995. Alright, plus the n minus 1 is always going to stay the same until we have an actual term number to plug in. And our common difference we just said was negative 5. So we would have to simplify this. A sub n is equal to 995. We distribute and get negative 5n, and a negative 5 times a negative 1 is a positive 5. We would combine our like terms. A sub n is equal to 1,000 minus 5n. And remember, this we can just plug in the term number, and we would be able to figure out the exact value for that term number. Now, we are asked, after how many students will there only be 15 nuggets left? So this isn't something we're going to be plugging in for n, because n is representing the number of students. What we are looking at is the 15 is actually going to be our a sub n. So we're going to plug it in on the left. And I'm going to use the explicit formula because it will let me find the term number. If I plug it in here, I'm only going to be able to find the previous term number. I'm going to have to go back a long way to get from 15 to 970 where we left off. So I am going to go ahead and use the explicit formula. A sub n is going to be 15, and we're getting that from the word problem right here. And that's going to equal 1,000 minus 5n. We are going to solve for n now, so we are going to we're going to subtract, rather, and let me erase that so that is clear. We are going to subtract 1,000 from both sides. And that is going to give me negative 985 is equal to negative 5n. We would divide both sides by a negative 5. When we divide a negative by a negative, we are going to get a positive. And we're going to get n is equal to 197. So after 197 students have gone through, we will have 15 chicken nuggets left, and the cafeteria should probably reorder some more. Just a note that could catch an easy mistake for you here. If you divided and you got a negative there, instead of dividing a negative and a negative and getting a positive, if you think about it, you can't have a negative 197 students, so that might be a little tip-off that you made a sign error. We always want to make sure our answers make sense. Alright, I will leave 2 and 3 up to you guys. So as I said at the beginning, this is the last application for 2C, so congratulations for making it through all the practice and all the applications. Study up for your last mastery check, and once you have passed that successfully, make sure you pick up the study guide for Unit 2C and start preparing for that last test. And we will be moving closely now into Unit 3. We're finally breaking out of the multiple parts of Unit 2, and we will start Unit 3, so we can't wait to see you guys there. See you later.